one population of people. These are the only people who are ever going to be interested in what you're doing, because you may get really surprised later on to find out that a product is much more fun in a different patient population and worth much more money. Back to stakeholders, talk to your stakeholders. Just because you have a product that is, you thought, this is best for orthopedics or neuroregeneration, you still need to be talking to every other field, every other customer, because they may come up with a totally different need than what you contemplated. Okay? Any questions on that? Any questions on visioneering?
Did you have to, when you found out, first of all, it was a very good day when you found out about that, the second edition.
Huge. Happy day.
But did you find out from research being done, did you have to do the clinical trials then, or was it for doctors prescribing it so that you, how did you have
So the people who filed our original paperwork with the FDA for our 510(k) clearance did something that they probably didn't appreciate what they were doing at the time. They put children into that clearance, and they put in the treatment of myopia in children, which is just nearsightedness, right? They didn't say anything about the progression of it or stopping the progression. All they said was, we're going to fix the distance vision in the nearsighted children, which is what a contact lens does. The really cool part of it is they put the children in there, not just adults. So what we're able to do is we don't have to go back to the FDA to say we stop the progression of the myopia in order for doctors to use our lenses on kids. They can use it on kids with the labeled claim that they're fixing the nearsightedness of the child, which they have to do anyways. They're going to have to put contact lenses on, they're going to have to put glasses on to fix that nearsightedness. We don't say anything about the myopia progression. And what's happening now is doctors have been using these lenses for a while on kids. They're starting to see that the kids stop progressing, the ones that are 6 to 9 months out now. And that data will get published. So they're starting to write up those abstracts now. One's a rapid communication, because this is super important stuff. Another's a case study. Eventually they'll have enough patients to actually write up a full paper. But meanwhile, we can sell it. We didn't have to go back for a claim.
Since you had that in your paperwork going regulatory from the very beginning, and great for that, did you have some pediatric clinical trials at the beginning?
The only clinical trial that we did was we showed that children wearing our lenses, we could actually fix their distance vision. We did this up in Canada and Asia. And that's all we did was show we can fix their distance vision as well as glasses. And meanwhile, you have all these other design components in the optics that everybody knows is going to stop the eye from growing. And that's all we did. And we also showed that they can take care of, they can put them in their eyeballs and they can take them out. They're daily disposable lenses, they just throw them away so they don't have to wash them. Didn't have to do all that. And since we filed patents around the use of our lenses and treating the progression of myopia. And it turns out this is what's going to sell this company. It's not the presbyopia.
Cool question, specifically about the application for progression. Which Asian demographic was it? Was it South Asian, East Asian?
If you want the largest market, it's China.
Okay.
If you want the most sort of, Singapore is an interesting place. Singapore, the government has called myopia progression an epidemic. So if you're going to go start in Asia, Singapore is a good place to start because the government is so anxious to get this problem solved, and they're doling out a lot of money for it. They're providing a lot of research support for it, a lot of investment support for it. China, huge population, huge opportunity, but even though we have patents there, it's really hard to enforce the patents. And the government is not really behind this as a big problem. And so you want to go where the money is, you want to go where the government support is, you want to go where the legal infrastructure will protect you. And China's the biggest, but it's not the best place to go in. So it's a country by country. Australia, strangely, is a bit of an enigma. High Asian population, but very low rates of myopia. That's right. Great Barrier Reef or some wicked cricket, whatever they play with it. Any other questions? Please.
Do your bifocal lenses work on individuals who have astigmatism as well? Because if I heard you correctly, you said that they're one-day disposable lenses?
They are.
The contact lenses I have are 3-month disposable lenses,
Okay.
because astigmatism
Yeah,
and
this thing,
far
they're expensive,
sightedness.
right?
Yeah,
Yeah.
so,
We can take about a diopter worth of cylinder, which is the measure of astigmatism is in cylinders. And we can take about a diopter of it and mask it. But beyond that, you would have to put astigmatic optics on our lens. And we're doing that in late 2016. So we're just getting done with the cylinder part, which goes on the inside of the lens, the optics tube. Our optics for presbyopia are on the outside of the lens, on the front surface. And as soon as we get done with the development of the cylinder part, we marry those and put them onto the same lens. But first we have to run the clinical trials with just it's called a toric lens is what you wear. We have to run it, run our clinical trials with a toric lens. We'll start selling those to people like, you, in a daily disposable, by the way. And then we'll take that and marry it up with the optics for the presbyopia, because an interesting thing about torics and presbyopia, everybody understand what I'm talking about? So the eyeball's supposed to be round, and if it's not, we call this spherical. If you squeeze it a little bit, just a little bit, the vision through the front of the eye will actually have an axis, because he just squeezes things, so it's going to be a little thicker along a line. And these patients require very special lenses to correct for the fact that one part of their eye is higher power because it's thicker than the other. In presbyopia, in the way these lenses are prescribed, it's every 10 degrees, right? So every 10 degrees, you have different powers of cylinder that you have to put in. So you can imagine in a doctor's office, if they're carrying a fit set of contact lenses, they have to have every distance power, they have to have every 10 degrees, and then for each one of those permutations, they have to have the actual cylinder power, which is going to be like -1, -2, -3. Thousands of SKUs to do this. If you put that on a multifocal, most multifocal bifocal contact lenses have 3 to 6 different reading powers. You take all those permutations and now you multiply it times 3 or 6, depending on what the presbyopic contact lens is. You can't do it, it's impossible. It is close to 20,000 different permutations of lens that you would have to carry in a doctor's office. It's not possible. You can't pay for it, they don't have the room for it. Our contact lens, what's really cool about it is we don't have add powers. We do things very, very differently. And some of you have probably seen my talk before where I describe how we actually do this. It's a very elegant solution. We don't have add powers. So that reduces by a factor of 6 relative to our competitors the number of lenses that it takes to do a presbyopic, multifocal, toric contact lens. Nobody can do this except for us. And so it's a very high priority project for us to get those optics married up, because nobody else can do it. Any other questions?
Recently, I've applied for a few PhD programs in bioengineering in order to hopefully bring products to market. So I want to know if, when I'm doing my doctorate, do you have any advice for me to be able to actually say, keep control of the product as, once I graduate, or be able to do it on my own and not have it be up to the PI or to the university?
Well, legally, your university owns it. Take control.
Does it change for
Even as a graduate student.
can you still get a percentage of it? For example, a couple of ones I applied to was Rice University and Georgia Tech. So it's one of those things where each university is different, where I can still get a controlling interest in, not full control, like a 5-10% or something.
Well, think about it from the university's perspective. They put years into developing this infrastructure that you're working in. You're borrowing the infrastructure that the university and its donors have built over decades, sometimes hundreds of years. And that's a lot of contribution from the university, quite a bit. They're going to get something for that. As a graduate student, it will completely depend on the university. And one thing, as you're looking at different graduate schools, it's really important to understand, if you plan on doing this commercializing stuff and inventing stuff, and maybe wanting to do a startup, understanding what their policies are. Because every university is different. And certainly private universities versus public universities, huge differences in how they handle intellectual property and the assignment of that intellectual property back to the inventors. And so, Georgia Tech, great place, one of the most progressive universities I know of in this regard. They're coupled up with Emory, which Emory is, it's a joint program there, biomedical engineering. Emory, they do things that very few universities do with regard to owning technology, the inventors owning technology, and especially how their technology transfer offices work. And you want to learn this stuff because it should be a factor in your decisions.
Okay, what is it, for example, they do different?
They pay bonuses to the agents who work in a tech transfer office based on how fast they get deals done and how many they get done. And it makes for a very efficient process. It's a process that's very difficult to do in public universities. Maybe you get bonuses, right?
Just got a $1,000 check today.
Yeah, $1,000 check for doing a license. There you go.
But it,
You're
just
$1.
one of the things to keep in mind is when you're looking at these programs and you're looking at opportunities is don't mix up control with money. There's control of your invention and different universities will have you involved in different ways in the invention process. But there's money, if the university makes money, how much do they share with the inventor? UofL gets 50%.
Which is generous.
Which is, you don't see universities higher than 50%. If you find one, let me know.
You never have control.
And the other thing that's really important is it's more important actually, is just the environment for entrepreneurialism. If you see somewhere like University of Louisville is very progressive when it comes to entrepreneurialism. Some universities are much less welcoming of mixing academics with commercial interests, even though for medical products, it's the only way to get them out. So you certainly want to look at just the macro environment of the university. If you're at Stanford, you invent something, doesn't matter how stupid it is, somebody's going to put some money into it. And it's because there's just so much money around there. It makes a difference. And they don't do stupid stuff. It's all good. Understand what I'm saying? Environment matters. Anybody else? Any more? I think we got some pizza out there in case you weren't sleepy enough.
Please join me in thanking.
Thank you.